friends, welcome to this video of Heron's formula. Today we will discuss about Heron's formula. Heron was a mathematician whose major work was on mensuration. Heron gave a famous formula to this world. Square root of s in brackets s minus a, s minus b, s minus c, which we use to find the area of a triangle. This is called Heron's formula. You must be wondering that if we already have the formula to calculate the area of a triangle, which is area of a triangle is equal to half base into height, then what is the need for this new formula? Well friends, the difference between the two formulas is that the area of a triangle equals half into base into height. Can only be used when we have information about both the base and the height of the triangle. Whereas, we can use Heron's formula to find the area of a triangle when we have information about all three sides of a triangle. Let's try to understand the given terms in Heron's formula. In this formula, S represents the semi-perimeter of the given triangle, whose value is obtained by dividing the perimeter of the triangle by 2. If the length of the sides of a triangle ABC are A, B and C respectively, then its semi-perimeter is S is equal to A plus B plus C divided by 2. And this expression in brackets S minus A, S minus B, S minus C represents the product of all the terms in parentheses by subtracting the measurement of all the sides from the semi-perimeter. That is, to find the area of a triangle, we just need to have information about the length of the sides of the triangle. To understand this better, let's look at this question. Sunil wants to sell his field. His field is in the form of a triangle, the length of each side being 5 meter, 9 meter and 10 meters respectively. He is getting rupees 1000 per meter square. Can you tell how much money will Sunil get on selling this field? Let's try to help Sunil by finding the answer to the question. If we name this triangular field as ABC and assume that the length of the sides AB, BC and CA of this triangle is 5 meter, 9 meter and 10 meters respectively, we can see that this is a scalene triangle. We can assume the side opposite angle A as A, the side opposite angle B as B and the side opposite angle C as C. So in triangle ABC, A is equal to 9 meter, B is equal to 10 meter and C is equal to 5 meter. Heron's formula for calculating the area of a triangle is square root S and within brackets S minus A, S minus B, S minus C, and its solution will be as follows. The perimeter of the triangle is 24 meters and its semi-perimeter will be 24 divided by 2, which is 12 meters. Now by finding the value of the terms within the brackets S minus A, S minus B and S minus C, with the help of the formula we will find the area. According to Heron's formula, this will be the area of triangle ABC. Here we can write 12 as 2 into 2 into 3. And now if we take out a number from the pairs of 2 and 3 from the bracket, that is 6 root 14 square meter. Friends, the value of root 14 is approximately 3.74165, and in this way, the total area of the field will be 22.449 or 22.45 square meter. The solution does not end here. We need to find the amount of money that Sunil will get on selling the field. For every square meter, Sunil gets rupees 1000. So for 22.45 square meters of field, he will get a total of 22,450 rupees. So friends, in this way, we can use Heron's formula to find the area of a triangle when we know the length of all its sides. In this session, we understood Heron's formula and saw its application with the help of a question. In the next session, we will solve some questions based on it. So see you in the next video. Thank you. Hello friends, welcome to this video on Heron's formula. In the previous video, we learned about Heron's formula. In this session, we will solve some more questions based on it. So let's start with this question. Find the area of the given figures. Look at the first figure carefully. This is an equilateral triangle and the length of all its sides is A. Here, we are not given any information about the height. We know that when we are given the length of all the sides of a triangle, then to find its area, we can use the Heron's formula. So let's start. Can you tell what will be the value of A, B and C here? All the three sides of the triangle are equal, so the value of all the three will be A. Now the formula will be like this. Square root S within bracket S minus A within brackets S minus A within brackets S minus A, which will be equal to square root S within brackets S minus A raised to the power of 3. Now we will determine the value of semi-perimeter, that is S. Semi-perimeter will be equal to A plus B plus C divided by 2, which will be equal to A plus A plus A divided by 2, or we can say 3A upon 2. We have obtained the value of S. Now we will find the value of S minus A within brackets and put it in the formula. S minus A is equal to A upon 2. Substituting in the formula, we will get within square root 3A divided by 2 multiplied by A divided by 2 raised to the power of 3. We can also write it in fractional form as follows, which will be, this expression is the formula for the area of an equilateral triangle. In the second figure also, we are given an equilateral triangle and the length of all its sides is 6 centimeters. To find its area, we can use this formula for the area of an equilateral triangle. In this way, we get the area as 9 square root 3 square centimeters. Now let's move to the next triangle. This is a right angle triangle whose hypotenuse is 10 centimeters and one side is 8 centimeters. You can find the length of the third side using the Pythagoras theorem. We will get xy equal to 6 centimeters. Now we know the length of all the three sides of the triangle. To find the area, we can use any of the two formulas given here. Let's use this formula. xy is perpendicular to yz. Between xy and yz, let's assume any one as the base. and the other as the height. We will get the area as 24 square centimeters. If you solve it using Heron's formula, then also you will get the same answer. We can see that if we know the length of all the three sides as well as the height, as in the case of right-angled triangle, then using the first formula, we get the area quickly. Now let's move to the next triangle. This is an isosceles triangle, the length of whose base QR is 8 centimeters and the length of sides PQ and RP is 5 centimeters respectively. Let's find its area using the Heron's formula. We will take the length of A, B and C as 8 centimeter, 5 centimeter and 5 centimeters respectively. Then we will find the semi-perimeter, which will be 9 centimeters. Now we will find the value of S minus A, S minus B and S minus C within brackets. We keep this value in Heron's formula and find the area of the triangle. We can write 3 multiplied by 3 in place of 9. In this way, this will become within square root, that is 3 multiplied by 4 within square root 1. The value of 1 within square root is 1. Thus, we will get the area of this triangle as 12 square centimeters. Can you find the area of this isosceles triangle using any other method? You can discuss it with your friends. With this, our video comes to an end, where we solved some questions based on Heron's formula. See you in the next video with some more questions based on this. Thank you. Hello friends, welcome to this video on Heron's formula. In the previous video, we solved some questions based on Heron's formula. In this session, we will solve some more questions based on it. So let's start with this question. A man wants to make a triangular flag, the ratio of whose sides is 5:7:8, and the perimeter of the triangle is 100 centimeter. How much cloth will go into making of such a flag? In the question, we are given the ratio of the sides of the flag is 5:7:8. In these three sides, one factor will be common, on multiplying with which we will get the measure of the sides of the flag. Agreed that the common factor is y. Then, the three sides of the triangular flag will be 5y centimeter, 7y centimeter and 8y centimeters respectively. Now we know that the perimeter of the triangle is equal to the sum of the lengths of all its three sides. So the perimeter of the flag is 5y plus 7y plus 8y. But in the question, we are given that the perimeter of the triangle is 100 centimeters. That is, this sum will be equal to 100 and the terms on the right upon addition will become 20y. This way, 20y is equal to 100 and on solving we get y as 5. Upon finding the value of y, we can find the length of all the sides of the flag. So 5y is equal to 5 into 5, which is equal to 25 centimeters. Similarly, 7y is equal to 7 into 5, which is equal to 35 centimeter, and 8y is equal to 8 into 5, which is 40 centimeters. Now we know the length of all the sides of the flag. As you can see, this is a scalene triangle and we don't know its height. Therefore, to find the area, we cannot use the formula half into base into height. We will use the Heron's formula here. Suppose A is equal to 25 centimeter, B is equal to 35 centimeter, and C is equal to 40 centimeters. Let's find the value of the semi-perimeter first, which we will get as 50 centimeters. Now, we will find the value of the terms in the bracket S minus A, S minus B, and S minus C. Now, we will find the area using Heron's formula. Friends, as you can see, this is a very big figure and we still have to find its square root. In such cases, it's easy to find the square root by writing it in the form of factors. Here, we can write 50 as 5 multiplied by 5 multiplied by 2, 25 as 5 multiplied by 5, and 15 as 5 multiplied by 3, and 10 as 5 multiplied by 2. Now friends, here the number 5 occurs 6 times and the number 2 occurs 2 times. By taking these numbers out of the square root, we will write the number 5 3 times and the number 2 once. And we will write the number 3 within square root. In this way, we will get our answer. Hence, the person will require 250 root 3 square centimeters of cloth to make the flag. Now let's move to the next question. Here, we are given the triangle ABC and the triangle DEC are congruent. Also, in the figure, we know that the length of some of the sides, so along with the areas of triangle ABC and triangle DEC, we need to find the area of the complete figure. Friends, as is given in the question, triangle ABC and triangle DEC are congruent, and we know that corresponding parts of corresponding triangles are equal, which means their corresponding sides will be equal. Hence, AB is equal to DE, BC is equal to EC, and AC is equal to DC. So the length of the side AB will be 7 centimeter, and in the triangle DEC, the length of EC will be 5 centimeters, and the length of DC will be 4 centimeters. Now we will use Heron's formula in the triangle ABC to find its area. Suppose A is equal to 5 centimeter, B is equal to 4 centimeters, and C is equal to 7 centimeters. First of all, we will find the semi-perimeter of the triangle ABC, which will be 8 centimeters. Now, we will find the values of S minus A, S minus B, and S minus C. Here are the values. Now let's put these values in Heron's formula. According to Heron's formula, upon simplification, we get the area of triangle ABC as 4 root 6 square centimeters. Friends, can you now find the area of triangle DEC? Will we again use Heron's formula? No. We know that triangle ABC and triangle DEC are congruent triangles, and the areas of congruent triangles are equal. So the area of triangle DEC will also be 4 root 6 square centimeters. Does the answer to this question end here? No. We have to find the area of the complete figure, which will be equal to the sum of the areas of triangle ABC and triangle DEC. So the area of this figure will be 8 root 6 square centimeters. Friends, that's all in this session. Today, we solved some questions related to Heron's formula. See you in the next class. Thank you.